Okay, this week we are looking at the cholesterol paper, the introduction in figure 1, to help answer some questions about LDLR protein levels. And in the first one, we're going to be looking at mRNA of LDL and how that affects cholesterol. Up on the board, I just have a sort of amalgamation of figure 1, and I have the second question sort of set up. So we are looking at LDL proteins, which are lipid-density proteins, which have an effect on the cholesterol. So the more LDL you have in your cells, the more cholesterol expression you might expect to see. The reason we know this is that we have LDL, which works through SREBP. SREBP works through a negative feedback loop, and that's how it affects LDL. We also know that AKT is involved in the cycle, and that from AKT we have MK2206, which is AKT acts as a regulator, so it upregulates the process, and MK2206 inhibits AKT. So in a cell that might have increased mRNA of LDL, we would expect to see higher levels of cholesterol because this would begin the process of cholesterol production. To give some information on that first question and answer the second question, I have this sort of combination from figure 1, showing figure 1a and figure 1b. I've removed the bottom line from both of the figures because I was just showing B tubulin, which is a housekeeping gene, and it was steady as expected throughout the entire thing. Instead here, I have figure A showing LDLR of the fed and starved cholesterol plates, and over here I have the same thing for B, of the fed and the starved. What figure 1A did was just observe LDLR through different concentrations of MK2206. They then found out that 5 was the most optimal. They then redid the experiment with just 5 over different timetables, found out that you see a change at 4 hours and that the optimal was around, I believe, 16 to 18. So what this shows is that in the presence of MK2206, which acts as a AKT inhibitor, that in the presence of MK206, you can expect to see increased levels of LDLR. There was diminishing returns, and that's why 5 was found to be most ideal. And in that graph, in the graph below figure 1A and figure 1B, you do see a slight decline in the graph after 24 hours, but it's very slight. And basically all the information that's important is that this is the optimal time slot, but it does start at 4 hours. So an increase of MK2206 we would expect them to see higher levels of LDLR. And we know this works through because of the AKT interaction, which then works with SREBP, which then affects the transcription cycle for LDL. To answer the second question, is just in 2 low cholesterol situations, except one is plated with MK2206, we would expect to see a greater amount in here and a lower amount in here